The multidimensional array is a fundamental data structure, but they don't exist in the C++ standard library. So we decided we would do our own. So why would we do that? Well, we've been working on this simulation framework called SciDevs. What SciDevs does, it lets different people write different simulation programs, connect them together, and run them together, sharing data between them. And we want them to share multidimensional array data. And so we wanted a common data type to do that. So that's why we wanted to do our own multidimensional array data type. We were sort of inspired by the Python NumPy package. Does anyone know Python NumPy? Yep, okay. Which lets you do things like this. So you can create two multidimensional arrays, A and B, and you can do things like this. You can go A plus B, and you get the result of adding all the corresponding elements. You can go, add 5 to each element. 5 minus A, divide each element by 2. You can do comparisons. Which elements of A are less than the elements of B? Which are equal? Which elements of A are at least 1, but at most 4? And you can ask questions like, are all the elements of A at least 0? Yes. Or are any of them 7? No. But this isn't Python code. This is C++ code that written using our multidimensional array class that we wrote for this SciDevs framework. So it's called array ND, like an array with any number of dimensions. When you actually create one, though, you don't have to use array ND. We suggest use one of these aliases. So you got array 1D for one-dimensional arrays, array 2D. So here we've got array 2D of int. You could have array 3D of float, whatever you want. Then you give it the dimensions 2 by 3, and then you give it the data. Or you can give it, if you want, give it one number and populate all the zeros, or you could give it a function. So here we're taking a lambda and using the lambda to populate all the elements. Okay, so we got a multidimensional array. You need to access one element, so you do that like this. You got use parentheses, index 1, 0, 3. You get one element. You can set it to 7. You could, instead of parentheses, you can also use square brackets, and that does exactly the same thing. But it's inefficient, because when you use the square brackets, it's actually constructing a new array each time you do that. So why would you do that? Why would you want square brackets if it's inefficient? Well, square brackets let you get multiple elements. They let you make a slice. So here we're gonna say from the first dimension take all the elements. From the second one, only take the elements index 1 and eliminate the dimension. And then for the third dimension, start at index 1 and then stride by 2, skip over every other element. And that gets you this subarray within the original one. And the new array, the slice shares memory with the original. So if I take the slice and we go dot fill 7, it's going to put 7s into the original array at the corresponding places, which is how NumPy works. And if you want, we can assign the slice to a new array, R2, and that shares memory with the original one. So if we go R2.fill7, it does the same thing. It changes the original array. If we don't want to share data, we want to copy, we just invoke copy at the end. Now R2 is a copy, so we can make R2 all 7s, but then the original array stays the same. Now we ran into, this works pretty good. We did run into one problem that we didn't anticipate. So this is the problem. Say you have a const array. The original array is const. Then you take a slice, but now the user just forgets to put the const on. They make the slice non-const. Unfortunately, we can't prevent that at compile time. And so then when you modify the slice, you actually change the const array. And so what we had to do then is throw in a runtime check. And so it fails at runtime instead of compile time. Unfortunate to not be able to make it perfect, but the class still seems to work pretty much pretty good all in all. So SciDevs array ND is open source. It's documented. The examples I showed you are online. If you want to check it out, just Google SciDevs and you'll be able to find it. Since we did that, another group made this XTensor library, which also does multidimensional arrays, and it looks quite good. So check out XTensor as well and compare your options. Thanks.